My name is Gretchen, and I'm a registered nurse. In this video today, I'm going to talk about the preparations of an alcohol through the hydration reactions of an alkene. Today, I'm going to explore the definition of hydration reaction, how the process works through the chemical equation of these reactions, and the use of Markovnikov's rule in determining the major and minor products of these reactions. And most importantly, I'd like to talk about the alcohol products and their everyday uses. So to begin, here's a quick definition of hydration reaction. It's a chemical reaction in which water is added to an unsaturated substrate. Let's take a look at ethene. It's a 2-carbon small molecule, and here it is in the condensed structure. And here it is in the line bond structure. So we're going to take our water molecule in the presence of a hydrogen ion, and we're going to react it with this ethene molecule. So to do so, we're going to take our hydrogen and our hydroxyl group, and we're going to place them above the double bond. Next, we're going to take our bonds, and we're going to take this bond, erase it, flip it, place it to the carbon atom, and we're going to take this bond, flip it, place it to this carbon atom, and here we have ethanol. Ethanol is commonly known as drinking alcohol, ETOH, or ethyl alcohol. Hey, bartender. When a patient is admitted into the hospital with alcohol intoxication, a blood alcohol test, or ethanol test, is run. This test determines the level of ethanol in the patient's blood. Knowing this level helps the doctors and nurses effectively treat the patient's symptoms of ethanol toxicity. These effects can be devastating. Next, I will use propene in a hydration reaction. We will end up with 2 separate products, a major product and a minor product. Let's take a look at Markovnikov's rule and then apply it. Markovnikov's rule states that to predict the major product, a hydrogen is added to the double bonded carbon atom that originally carried the most hydrogens. Let's try it. We have propene plus water in the presence of hydrogen. So using Markovnikov's rule, we're going to place the hydrogen above the carbon that has more hydrogen, and the hydroxy group above the other hydrogen. Next, we're going to erase this double bond, flip it up, and then we're going to erase this bond and flip it down to that carbon. And we end up with 2-propanol. Next, to get the minor product, we're going to take our hydrogen and we're going to place it above the carbon with the least amount of hydrogens, and the hydroxy group above the other carbon. And again, we're going to take our double bond, we're going to flip it up, we're going to take this bond, we're going to flip that down, and we end up with 1-propanol. Let's take a look at some everyday uses of these products. 1-propanol. The minor product is used as a solvent in the pharmaceutical industry. 2-propanol. The major product, also known as isopropyl alcohol, is also used as a solvent in industrial processes. Here's an isopropyl alcohol prep pad used as an antiseptic. It contains isopropyl alcohol 70% volume for volume percentage. As a nurse, I use these products every day and now can appreciate the process of a hydration reaction on an alkene. So I hope your takeaway today is to remember how to bond the hydrogen ion and the hydroxy group on the carbons across the double bond, and to use Markovnikov's rule to determine the major product and the minor product. So in the end, your product will be an alcohol, whether it's this alcohol, or a host of any other alcohols. Thanks for your time. Cheers.